Welcome back for a second example of using squeeze theorem to prove that a sequence converges. We're going to look at a neat sequence, 1 over n factorial. We're going to prove that that sequence converges to 0. So let's recall how the squeeze theorem works. We need to show a relationship among 3 sequences. We need to show this double inequality holds at least for all but maybe the first n terms, so we can ignore the first n terms, the first finite number of terms, as long as we can prove this is true for the remaining infinite number of terms. And if we can show these 2 sequences converge to the same limit, the 2 sequences on the end, if they converge to L, then that middle sequence also converges to L. Okay, and kind of the steps go: find 2 sequences that bound your unknown sequence, show that their limits exist, and then use the squeeze theorem to conclude that the limit of the unknown sequence exists. Okay. Well, one thing we can observe, since n is positive, n factorial is positive, and its reciprocal 1 over n factorial is positive. That's kind of a gimme. And in most Calc 2 classes, it's shown by induction. And this is kind of the standard way of showing that 1 over n factorial is bounded. It can be shown that for at least n greater than or equal to 4, n factorial is greater than or equal to 2 to the n. Yeah. Well, that implies that the reciprocal of n factorial is less than or equal to the reciprocal of 2 to the n. Okay. So what do we have together here with these 2 statements? 1 over n factorial is is greater than 0. 1 over n factorial is less than or equal to this sequence. Thus, we have 0 less than or equal to 1 over n factorial less than or equal to 1 over 2 to the n. Okay. So we can't use any standard or any more elementary techniques to find the limit as n goes to infinity of this guy with the factorial in the denominator. But we know how these others behave. And this is a constant sequence, so it clearly goes to 0. And 1 over 2 to the n, as n goes to infinity, 2 to the n grows without band, and it goes to 0. So note the reciprocal of 2 to the n goes to 0. In fact, for any a to the negative n where a is bigger than 1, a to the negative n goes to 0. Okay. Okay. So we have our function bounded. Both of the bookend sequence go to 0, and therefore, by the squeeze theorem, our sequence goes to 0. And so more formally, the limit as n goes to infinity of 1 over n factorial equals 0.